Hi, and welcome to this session for getting your apps connected with networking APIs. My name is Lillian Zen, and I am a program manager in the Wireless and Core Connectivity group. Before we start, I'll give you a quick overview of what is going to be covered in this session. First, we'll go over the existing problem space and prior solutions to those problems. Then I'll introduce what is new in Windows 10. I'll show you some sample code and some demos, and then I'll leave you with some next steps for what you could investigate if you're interested in learning more. So what is the problem? Users are not always connected, and when your app requires network connectivity to work its magic, that could be a problem. So your app could lack network connectivity for a number of reasons. For example, your wireless or Bluetooth radios could be off. You could be in an area with an unknown Wi-Fi network to which you have not actually connected yet. Or you could be in an area with no Wi-Fi connectivity at all. So prior solutions to this have been very cumbersome at best. On the desktop, you had to actually move the user out of app context in order to fix those problems. For example, navigating through the settings menu to connect to a Wi-Fi network, or to toggle radios on and off, or to start internet connection sharing. You could also swipe out from the charms bar to manually connect to a wireless network. On the phone, this experience is somewhat better, but it's still not the best. So on the phone, as of Windows 8.1, there is the Quick Actions toolbar that you can swipe down from the top to toggle on the Wi-Fi and Bluetooth radios manually. There's also a settings link URI experience where you could go direct the user to another subpage, but that would still require some user interference. So in Windows 10, we wanted to provide some new APIs that would make this user experience more seamless and give the developer a little more control over the user experience. So here we have three sets of APIs that we are adding to Windows 10. The first of these is the radio management APIs, which allow developers to toggle the Wi-Fi and Bluetooth radios on and off. These APIs are publicly available as long as the developers declare the radio's device capability. There's also a settings page available for letting users manage this capability, which I will show later on. The second of these APIs are collectively known as the Wi-Fi Scan and Connect APIs. As their name suggests, they allow devices and apps to scan for Wi-Fi networks within range and retrieve certain properties such as SSID and BSSID. They also allow the apps to connect to common types of Wi-Fi networks. There are some restrictions on these APIs. For example, they cannot run from a background process, but again, they are publicly available, and an app that wishes to use these APIs only needs to declare the Wi-Fi control device capability. You will find this in the Windows Devices.Wi-Fi namespace, and the previous APIs, the radio management APIs, you can find in the Windows.Devices.Radios namespace. Finally, we have the tethering APIs, also known as Mobile Hotspot. These aren't entirely new. They actually existed in Windows 8.1, but they were only available to second-party network operators. In Windows 10, we are making them publicly available so that any person or any app developer can start a mobile hotspot on the user's device. So let's step through a bit of sample code for each of these APIs. The first one of these is the radio management APIs, which, if we go through this, allows the user to seamlessly toggle on and off the radios without having to go to any settings pages. So to step through the sample code, we first have the request access async call, which basically allows the app to have access to the radios in general. This must be called once from the UI thread in order to grant the app access. The next call is the get radios async enumeration call, which basically gets all the instances of the radios on the system. So whether they're Bluetooth or Wi-Fi radios or other, this will be returned in a list. So next, if I wanted to turn the Wi-Fi radio on specifically, I would first check to see if the radio kind was Wi-Fi, and then just set state async to radio state.on. What kinds of apps could find this useful? First of all, any app that needs network connectivity in general but doesn't want to ask the user to go through all those actions to actually set the radio state on, that will be useful. But there are also certain NFC and task automation apps, for example, which may find these sets of APIs very useful to their scenarios indeed. So now I'm going to switch over to my demo for the Radio Manager APIs. So here we have the Radio Manager application to demonstrate the Radio Manager APIs. For the purposes of this demonstration, I'm going to show the Wi-Fi toggle, just because you can see the status of it over here in the system tray. So I'm going to go over here and turn the Wi-Fi radio off You should see over here the Wi-Fi radio has indeed been turned off. I will do the opposite, turning it back on, and voila, there it goes, and I am automatically connected to a Wi-Fi network. I mentioned before that there's a settings page for managing which apps have access to this capability. If you go to privacy and then to radios, you should see that there is both a master switch for controlling whether apps can set the state of your radios at all, as well as a per app settings toggle. So for example, if I were to go here, toggle the permission off for my radio manager SDK sample, and then I go back here, not there, to here, and I try to toggle the Wi-Fi radio again, I just can't. I do not have access. So back to the presentation. So now I will go over some sample code for Wi-Fi scanning and Wi-Fi connecting. Again, we see this request access async pattern, which allows the app to have access to the Wi-Fi adapter for any operation. And I check the access status to see if I have that permission. Then I go through a enumeration pattern. This is the Windows.devices .enumeration pattern for find all async, which is a little bit more roundabout for enumerating the Wi-Fi adapters on the system, but I'll show a simpler one later on. I say Wi-Fi radios because it's entirely possible for a device or system to have more than one Wi-Fi adapter at any time. So if I go here, I find all async. I use an AQS query string, which is represented here by the Wi-Fi adapter.getDeviceSelector call. And then I check to see if I have any results. It turns out if I do have one, then I will just take the first adapter, which is returned by this call, usually just the default adapter, and then I can go and start my scanning operation. So if I go on to the next screen here, then you can see some code for actually initiating this scan. So I have first adapter.scan async that initiates the driver scan and populates a list of networks that are within range, seen here through the network report attribute. So I get a report that is populated with a list of the available networks within range, and then I can access each available network and retrieve certain properties, such as SSID, BSSID, signal strength, otherwise known as RSSI, and channel center frequency. There are a whole number of other properties that are available, and you can see them later in the documentation. Okay. So if you were to use the Wi-Fi scan API by itself, you could use it to build such applications as a Wi-Fi channel analyzer, which essentially allows people to determine which frequencies and signal strengths are best for situating new wireless routers. So it's entirely possible to use the scan APIs without the connect APIs. So now to go on to the Wi-Fi connection portion of this exercise, we have some more sample code using the available networks that were returned from the Wi-Fi scanning portion. We are just going to take the first one, and let's say that it is a network that requires a simple password. For the purposes of this demo, I have the password actually set to password, though I hope you don't actually set your password as that simple string. And I create a password credential using that passphrase, and that is also a well-known class that already exists. Okay, then I use a connect async operation to pass in both the available network that was retrieved as a result of the scan operation, the kind of connection that I want it to be, which in this case is permanent, not temporary, and the password credentials. And then hopefully I'm successful, but if not, then I want to display to the user that the connection failed. So now I'm going to switch over to the Wi-Fi scan and connect part of this demo. All right, so here is the Wi-Fi scan demo. It has 4 different scenarios. I'm only going to demonstrate the second and fourth one, scan and connect, respectively. I'm going to switch over here and hit the wonderful scan button. So I see a list of networks that has been returned by the scan. Pretty simple and straightforward. You can see that it has given me various properties like the BSSIDs of the routers that I see, and frequency, and the encryption type. It also shows me whether I'm connected to that specific network. I'm going to switch over to scenario 4 here, connect, hit the scan button again, and then actually do something with the information that the scan results return. So I'm going to go and connect to MSFT Open. And as you can see here, it doesn't require a password. I can choose whether or not to auto reconnect. I'm just going to go ahead and hit connect. You see here that I was momentarily without connectivity, but now I am connected to a Wi-Fi network, which is pretty cool. So now I'm going to switch back to the presentation. So next we have some sample code for the tethering APIs, also known as mobile hotspot. I don't have a demo for this, but this has existed since Windows 8.1, so you can find some more sample apps there if necessary. The tethering APIs allow an app to share its internet connection over the cellular radio and cellular connection with other devices. So the Windows 10 APIs will allow apps to seamlessly start sharing their mobile hotspot with other devices. So the first step in this sequence of calls here is to create a tethering manager. We've set one to null because we're not sure if we are connected to cell yet. That is the first check that proceeds in this bit of sample code here. So I see if I have an internet connection profile currently, and then I check to see if it is a WWAN connection profile, another name for the cellular connection. So if I am indeed connected, and if I do have a connection over cellular, then I can retrieve a tethering manager and create it from that connection profile. Then the next step in this is to try actually connecting, or to start tethering. So I have tethering manager.start tethering async, and then I can check to see whether that operation failed or succeeded. So that is all of the APIs that I had to show. If you're interested in learning more later on, you can follow the links within this presentation to find some MSDN documentation and sample apps for the Windows 10 APIs. And finally, if you're interested in learning more about the connectivity and networking solutions offered in Windows 10, then I recommend that you check out the Wi-Fi Direct and Wi-Fi Direct Services talk linked below. Thank you very much, and I hope you enjoyed this presentation.